this one. This is a very common thing. Okay, so what I was saying that in mathematics 2 plus 3 equals to 5, that holds, and irrespective of any unit, any object, that will hold in nature. A similar thing, we need to have a, it has to hold in probability and statistics, where what you will observe, that is not predetermined. So that number is a random number, and some law of addition, multiplication, division, and all those things must hold, and further operations can be possible uh, with this kind of observation. And whatever will hold by pen and paper or computer simulation, we will expect that the similar thing should hold in nature also. Outside world, we are supposed to get the same thing if our model is correct. And that modeling starts with the introduction of random variable, or properly assign random variable to the situation. So let's start with an example, and gradually we will move for the theoretical results. So in general, when we start with random variables, it is theoretically needed that we start with a probability space. That we have already defined, that it will have a set omega, non-empty set, a sigma field associated to it, and a probability function. So this is the thing first we need. At the top of it, we will define random variable. So let's start with an example such that things become much more clear conceptually. Suppose the random experiment is this. A coin is tossed 3 times. A coin is tossed 3 times independently. And also assume that probability of getting head is P equals to 1 minus probability of getting tail. Okay. So let us keep the thing much more simple. Now, if a coin is tossed 3 times, then what can be the omega? All possible outcomes. All possible outcomes, it could be head, 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 then head, head, tail, head, tail, head, tail, head, head, then head, tail, 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 head, tail, 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 head, and tail, tail, tail. So how many outcomes are there? This is omega, right? How many? 2 to the power 3 outcomes. Okay. Now, what we do, we assign some number to head or tail. And with that assignment, you can also have some story behind. So let us just, if we define that the total number of head, so if we can assign for many different purposes. Okay, so first of all, let us define u, a variable, which is the total number of head. Okay. So how many heads are there? There are 3 heads. For each of them, next 3 outcomes, we have 2 heads, 2 heads, and 2 heads. Then 1 head, 1 head, 1 head, and the last one, there is no. It is quite simple. Now the same story can be told in this way, that if head comes, I will get 1 rupees. If tail comes, you will get 1. So for head, it is +1 for me, and for tail, it is -1 for me. So how can you convert this thing? So at least let us consider another variable, which is in this way, v, which talks about +1 for head and -1 for tail. Okay, so now what could be the possible values of v? The first one is 3. Second one, how much?
1.
1.
1. So this is 1, this is 1. What will be this one? Fifth one?
-1.
-1, -1, -1, and the last one
-3.
-3, right? So these are the possible. So now if I change the story in a different way, the numbers associated to this same outcome will be different. Okay. The same thing you can also redefine in this way. Let me know if you agree with me or not, that with head is assigned to 1, tail is assigned to 0, and this law of assignment, let us call x of head is 1 and x of tail is 0. So here I can say that I have tossed 3 times, and 3 times I am checking as you do counting, yes or no type. Then this thing is nothing but a 3 replicate of x1, x2, x3. Okay, and formally we can define u equals to x1, outcome of first toss, plus x2 plus x3, outcome of second toss, plus x3. So this is how we got u. Now if we define another number y, which is a function of x, so y equals to 1 if x equals to 1, y equals to -1 if x equals to 0. Then how can you define that number as a function of x? Check whether can you define in this way. So y equals to 1. Is it satisfied?
Yes. Yes, sir.
Okay.
Yes,
This
sir.
is very trivial construction, but this is the fundamental thing. We can extend it at any level. So y can be constructed, and now you can call v equals to some y1 plus y2 plus y3, which are the replicate of y. So from the first outcome you will get y1, from the second outcome you will get y2, and from the third outcome you will get y3. So as a consequence you get v. Now you notice the thing. From here we can also extend the idea in this way, that we have a pair u of I mean um, u of head head head. This is 3, and v of head head head. This is also 3. U of head head tail. This is 2. V of head head tail. This is 1, and so on and so forth, as you can see in this. So you can also have a pair, and not only that, you can extend in for other. You can define W in a different way. So not only two component, you can make it 3 component. Not only 3 component, you can make it 4 components. So you can get a vector. Okay, in general. So this is how the idea evolves and idea extends. So what eventually we are doing here? What we are doing these things that assign real number to the elements of omega. So what we are operationally doing? Assign real numbers to the elements of omega. And as a consequence, that also implies we can get that assign vector to the elements of omega. And also another thing, so this is so for one, so let us call 1a, 1b. So assigning real number to omega, maybe say this is the example. So this is an example of 1a, 1a, and as a combination of them, this is the example of 1b, that assigning a vector to omega, each of the element of omega. Now, also you have seen that, well, I am writing with a very lucid way, or maybe say not formal way, some nice function of uh, nice function of these outcomes of the functions composed to the initial function, that means this x or u or v is also a mapping from omega to r. And most important thing, what people often neglect here, that all these functions are deterministic. Okay. So whatever we have got here, we have a proper mathematical function which will take us from omega to r, or in general Rn. This is the thing that we got here, nothing more than that. Okay. So here I have not explained this term nice. We will try to explain. We have not, don't have the scope to define it mathematically here, but we will try to explain what does it mean. So the idea is this: whatever will be the outcome of a random experiment, we will try to assign real number or vector to each of the element of this set, and then we will deal with those numbers or vectors. And this assignment, this law of assignment is known as random variable. Random variable is a deterministic function which is mapping from sample space to real line or Rn. It is, remember, it is a deterministic function which assigns a random number or which assigns a number or a vector to the outcome of a random experiment. So often students, I mean, not all, some of them say that what is a random variable? If you ask, the answer comes like that: a variable which is random. That is a completely wrong definition. It is a deterministic method or function which assigns a real number or a vector to each of the outcome of a random experiment. So any doubt, any query here, please let me know before we go for the formal definition. Let me know if you have any query. Anybody?
Sir,
Yes.
in the example of 1b, we are taking the value of u comma v as an ordered pair, right?
U comma v as an ordered pair, yes.
Sir, then is it necessary that to each outcome a unique thing, a unique vector must be assigned, or we can assign the same vector to multiple?
I
Means
didn't
the
get your point. So
like
when you say UV, then for each of the outcome you have to define that thing first.
sir,
For
in this example, HHT and HTH, both of them have 2 comma 1, so the function can be many one. It is not necessary to be 1 1. That is my doubt.
no, I have never told one. It can be many.
Oh, okay, sir.
Function admits that thing many to one, but the reverse is not true. Okay, many point can go to 1 point, but 1 point too many points, that is not allowed in function by definition, right?
Yes, sir. Yes.
That is the. So we are calling the function in a proper way, that from, and you will see that what interesting thing that gives us when many to one comes together. Okay, so let us go for that. So here we are now, whatever we have explained, we are trying to make it more abstract and formal. Okay, so let omega script A P be a probability space and X is a function from omega to r. For the time being, let us restrict to r, and then naturally we can extend such that x omega, small omega, belongs to r when small omega you can think of like head, tail, head. Each of the elements of small omega belongs to capital omega. And this is a crucial thing that we are trying to make it more formal. That x inverse of minus infinity to small x. So open, this is closed. X inverse of this interval is collection of all such omega such that x omega less than equals to small x belongs to script A for all x belongs to. Okay, check this thing. X is a function from omega to r such that any element if you choose from capital omega, it will give a number from real line. Not only that, for any real number you choose, and then you invert that function minus infinity to x, invert that function, then you will get a collection of omega which is satisfying this condition. It is trivial from here. And not only that, this collection has to belong from the sigma field. That's why we have started with this assumption that omega A P. So if this quantity belongs to this set, then only we know its probability. Otherwise, we don't know its probability. So that is the thing we have seen in one example in the last lecture, that only the sets which belongs to the sigma field, we know the probability of them. Otherwise, we don't know the probability of them. So if this condition holds, then we call x, which is a mapping from omega to r or function from omega to r, is a random variable on omega A. So this is the complete definition of random variable that you can think of. Okay, so at your level, this much we can technically say. It can be made more sophisticated and more technical, but at your level, whatever previous knowledge you have and training you have, based on that, we can have this definition. Remember, this set what we are talking here is minus infinity open, left side, x closed, and with more general structure, it can be done for both open, both closed, half open, half closed for all of the sets. But for the definition, we are using minus infinity open from left side and x closed, x included. That's why it comes like x omega less than equals to small x for all x belongs to R. So this is the definition of random variable. And now from here, what we can do is we can immediately calculate from here. We can immediately calculate a few more things like this, that we can calculate the probability x less than equals to small x. This probability we will be able to calculate from here. How? So let me just check that. Say for example, if I say that x equals to small x, so in general, so can be calculated. Okay, so this is the new possibility that we have got from here. And this thing, probability x equals to small x, which is often denoted by capital F of x, or also denoted in this way, that f of fx x, and the meaning of this thing is defined through this structure, that this is the probability of the set of omega such that x omega less than equals to small x. So, and this element belongs to sigma field, so we can talk about its probability. So now, using this result, if we consider, say for example, if you consider V that we have defined here, if we go for calculating the probability, then let us see how we can. So probability capital V, which is, so let us say, what is the probability that capital V less than minus 4? Can you please tell me? From here, capital V less than minus 4.
0, sir.
0. So eventually it is probability of null set, and hence it is 0. Now if I say what is probability V less than minus 3,
Zero.
again 0, because minus 3 is not included here. Okay. Now probability V less than equals to 3,
1.
1.
sorry, okay, less than equals to 3. Okay, so let us go by 1 gradually. So now please tell me.
1,
1/8.
1/8.
Say, you know that probability of head is P and probability of tail is 1 minus P. So is it not that this is the element, if you go by this definition, only tail is satisfying this condition, P of omega such that x omega less than equals to small x. So V omega less than equals to minus 3. And TTT is the only point which is satisfying this thing. So what will be the probability?
1/8.
Where did you get 8?
1 minus p cube.
1 minus p whole cube.
1 minus P whole cube.
Yes, sir. Sorry.
Forget about that all probability half. So 1 minus P whole cube. Okay, now if I ask, say V less than equals to minus 2.5, what will you get?
Same. 1 minus p cube.
Again 1 minus P cube. Achha. Now V less than equals to minus 2. Sorry. Okay. चलो बोलो -2.
Same, sir. 1 minus p whole cube.
Again 1 minus p whole. So this is same thing. Don't get bored. Now v less than equals to -1. I am not repeating. I think you have got the idea. What will be this one? So
1 minus p cube plus 3 times of p into 1 minus p square.
So for each of them, probability is p into 1 minus p whole square. So for each of them.
Yes, sir.
So this one plus 3 times this one. So this is probability tail, tail, tail. Tail, tail, head, tail, head, tail, head, tail, tail. So this is the omegas which are satisfying this kind of condition, and probability of this is 1 minus p whole cube plus 3 times 1 minus p squared into p. Okay, so let us complete our journey. So what will be v less than equals to 0?
Same, sir.
Same. 1 minus p whole cube plus 3 times p 1 minus p whole square. Okay. Probability v less than equals to 1. What will be these probabilities individually?
Square into 1 minus p.
P square
1 minus
into
p into
1.
p square.
All of them individually. So this plus 3 times this plus 3 times this. Okay. So I am not writing the set once again. So this is 1 minus p whole cube plus 3 times p 1 minus p whole square plus 3 times p square 1 minus p. Okay, and finally probability v less than equals to 3. What will be that one? Is 1.
1.
Yeah. And probability v less than equals to 4.
1.
1. So now onwards, whatever you choose, all will be 1. Okay. Now, if you plot this function, probability x less than equals to small x belongs to real line. So in this axis, x, and this axis, probability x less than equals to small x. So you can go by v, whatever may be. And whatever function you plot from here, this function is known as cumulative distribution function. In short, CDF. So this is the definition of cumulative distribution function, and in short it is known as CDF. So now can you please plot it, or let us give it a try, that how it will look, or please tell me from your idea?
Yes,
What
yes.
kind of function it will be?
Sir, it will be like a discontinuous function, sir.
Of course, this continuous function,
And
correct?
means like a step function, sir. It will change at -3, -1, 1, and 3.
Okay, very good. It will be a step function, and
Yes.
it will change the value at -3,
-1,
-1,
1,
-3, -1, 1,
1,
and 3.
and 3.
Right.
Yes, sir.
Okay.
Sir,
Any
it will be
other?
increasing.
It will be
Non-decreasing.
non-decreasing. The proper
Yeah,
term will
non-decreasing.
be non-decreasing. When it is
Non-decreasing. Yes,
there is
sir.
a step flat plateau, then it will be non-decreasing. Okay. So now let us try to just plot it so that the image will be clear in our mind. Okay,
Sir, why it will be discontinuous? Because x
okay.
belongs to all real, so it can be
Of course,
we can
of
define for all real values.
yes, of course we can do. And we have defined it for all real values. So this is the function fx, or okay, which is mapping from real number to 0 to 1, and the definition is this: fx equals to probability x less than equals to small x, which is nothing minus infinity to small x, which is nothing but probability of the collection of all omega such that x omega, this is the same meaning, x omega belongs to minus infinity to small x. And I think that's it. Uh, Probability of this thing, or you can also say that probability of x inverse minus infinity to x. This is the same thing. Now let us try to see that if we draw this thing, say for example, here let us call 0, here -1, maybe, okay, so here let us call -1, -2, -3, here +1, here +2, and here +3. Okay. So before reaching to 0, before reaching to -3, the value is 0. That we have already seen. Before reaching to -3. So unless you reach -3, the value is 0. Whenever you reach 3, then there is a jump, and the value becomes 1 minus p q. So the amount of jump here is 1 minus p q. And then this value continues. This value continues until you reach to -1. So until you reach to -1, the same value continues. Okay. And when you come to -1, then there is again a jump, and the amount of jump is 3 times. The amount of jump is 3 times this quantity.
P into 1 minus P square.
P into 1 minus P square. And then you are in this plane, or this location. Then again the value retains the same until you reach to 1. So you reach to 1, and until this point the values are same, and then again you have a jump. How much amount of jump here? 3 times p square 1 minus p. So that amount of jump. So from here to here, this gap is 3 times p square 1 minus. And then again you continue up to unless you reach to 3. So from here to unless you reach to 3, you continue with this number, and then again there is a jump which is how much? P square p cube. And then this number is 1 and 1 is continuing throughout, and this number is 0. So this is how it will look. So now do you have any doubt why it is discontinuous? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Yeah, thank you. So this is the and so here this side we have fx, and this side we have x, or maybe say fv, we can say f small v, and no problem. It is demi variable, doesn't that, and v belongs to the real one. So that's all. And this is cumulative distribution function, CDF. And for a random variable, cumulative distribution function uniquely identifies its feature. If you know cumulative distribution function, you know everything about the random variable. So this is the important note, that CDF uniquely identifies a random variable. That means you know everything about the random variable if you know its cumulative distribution. So again, and here we will maybe next day, let us see, we will define what is discrete or continuous.
Sir,
So
if you
let us talk about, yes,
definition of
inquiry.
random variable. Sir,
Say again.
I have a doubt in the definition of random variable.
Okay, tell me.
Isn't the second part of the definition trivial? If you have a function, won't it automatically satisfy that condition where x inverse from minus infinity to x gives omega, and then x of omega should be less than or equal to x? Like, isn't the
Well,
second part trivial for any
no,
function?
no. The fact is that if you remember the previous example that you have seen, that all set may not belong to your sigma field. Your
Okay.
sigma field must contain that event.
Okay, so omega belonging to that script A is
Omega
important.
belong omega. So if this satisfies, and if your sigma field contains that set, then only you can have the probability of that number, or sorry,
Okay.
that set. So x less than equals to small x, if you have defined. So I mean, constructing such kind of more complicated examples, I am not going for that. But the point is, if I have such collection of omega, and that collection doesn't belong to the sigma field, then there will be a problem. Usually for this kind of finite thing or countable thing, there is no problem. Problem
So the
happens when you are
okay.
dealing with entire real line or Rn. Then the problem often occurs. There are many sets comes such that inverse function doesn't belong to the collection of sigma. Because when this is not in your course, or maybe not definitely in any first course of probability, that the collection, if you consider the outcome, say omega is the real number, or 0 to 1, and if you consider the collection of all possible subsets, that means the power set, it becomes so huge Then mathematically it can be argued, I am not going for that in details, it can be argued that the cardinality of that set becomes even larger than the real number. So this inversion becomes really problematic. So to avoid all those high level technicalities, we define the random variable in such a way that whenever you will invert the inverted set, which is a subset of omega, definitely you can see that all these elements are subset of omega, and that subset belongs to the sigma field. And by trivial this example, we have taken the sigma field as a power set because here are only 8 elements in the omega, so power set of omega is well tractable thing for us. Is it okay? So if you are really interested, you read maybe at this level you read a very good book of real analysis, and if you are still not satisfied, then sometime you take the course of measure theory. All this thing will be clear to you, and you will get a new definition of integration there, which is apart. Not apart from Riemann integration that you have learned in 10+2 level, and that gives the the advantage to have probability theory. So in general, the Riemann integration coincides with that new integration is defined in measure theory. Some very often when the Riemann integration holds, then in your course we will assume everything will be Riemann integration doable, Riemann differentiation doable, but in advanced courses, Riemann integration often fails. Then we need to introduce many different aspects of integration and differentiation, and the entire probability theory are based on that integration. So we are not going for that. For your course, we will assume that the Riemann integration will be doable and it will serve our purpose. Okay, so just to conclude from here, let me write down the properties of the CDFs, which are very much important. So the properties of CDF. Okay, so first one is f of minus infinity. What does it mean? That probability x less than equals to minus infinity, and that is also in this sense that limit x goes to minus infinity from top fx, that quantity is 0, that you already know. Second property, if x goes to plus infinity, probability x less than equals to plus infinity is limit x goes to plus. I think I should not write it this way. This is not a good notation, but this meaning is same. X goes to plus infinity, that is 1. Third thing, if x is less than equals to fy for all x less than equals to y. Okay, belongs to R. So this is non-decreasing property. And the fourth one is, remember, f of a, which is limit x coming from above to a, that means from right side, fx for all x, this limit exists, belongs to R, and that is known as the right continuity. So if you are really interested for the proof of all these properties, you can see any of the textbook suggested. Clear proofs are given by Rohatgi, and as well as Whale-Port and Stone. I hope you will get the proofs in Hogg and Craig's book, may or may not be, and Rice book. So any book you can refer to just for the formal proof. I'm not going for the formal proof of all of this, but remember, these things are trivial. As x goes to minus infinity, it is 0. At x goes to plus infinity, it is 1. X is when x is less than y. Say for example, x is here, x is here, and y is here. Trivially, the fx value is larger than, fy value is larger than. So if you can consider x is here, y is here, then the fy value is larger than fx value. That holds. But if x is here and say y prime is here, then fx value is same as fy prime value. So if x is strictly less than y, then fx is strictly less than fy, or fx is same as fy. That's why this thing holds, that fx is less than equals to fy. Now the finally, fa equals to limit x coming from right. So coming from right side. So x is gradually decreasing to a. So if you choose any point, so this is a. So if x is gradually decreasing to a, then it will have the limit as fa, and that thing will hold, say, for this boundary points also. Suppose either this boundary point, this boundary point, this boundary. So if you come from this side, it will hold. But if you go from this side, that need not hold. So it is right continuous, need not be left continuous. So non-decreasing right continuity, at minus infinity it is 0, at plus infinity it is 1. So that is the property of a random variable, a CDF, property of a CDF. Now another note, this is beyond the scope of proof, that if a function gx satisfies all these properties of a CDF, then there exists a random variable. So if you can find a function which is satisfying all these 4 properties, then there must be a random variable. And what do we mean by random variable? A function which will be satisfying all these conditions, as well as you will have a probability structure. So that is the thing that you can ensure from here, that the reverse is also true, that if these 4 properties are satisfied by a function, any general function gx from real number to 0 to 1, then there must be a random variable associated to it. So this completes the journey of the definition of random variable and CDF. Tomorrow's class, we will define what is known as the discrete random variable and what is known as the continuous random variable. So to do this, I think not much technical thing will be required, but at least you, and its moments also we'll talk about, at least you revise the sum of series. I hope you have done in the Math 1 or Math 2 that limit and there, if you increase the limit of partial sum, then how does it go? Summability conditions. This thing you revise and come to the class for tomorrow. Okay. So I think,
Sir?
well, yes, please.
Sir, I have a doubt on the fourth definition, the
Well,
fourth property.
yeah, well.
Sir, what
So
will happen if
here,
we take,
mhm, well,
sir,
yes,
what will
right.
happen if we take A as 0.999?
A as whatever 0.
The fourth,
Okay, so 0.999. So this limit will still be here. If you go from this side, the limit, left hand limit will be here, and if you come from right hand side, the limit will be here.
sir, but 0.999 will be on the second step, right? And when we come from right, it will
Yeah,
be a
when
discontinuity.
you will come from right, it will be 1.0000001, something like that, and it will be here. And 0.99999, that will, here is 0, so 0.9999, that will be ending up here.
Yes, sir. Sir, so isn't it a discontinuity?
Yes, it is discontinued. There is no doubt that it is a discontinuous function. It is discontinuous function.
Sir, which means this function is not satisfying the properties of CDF.
Why? These are the
So
properties of
because,
CDF.
sir, because of the fourth
I have
property.
never told that it will be continuous function. I have told that it will satisfy the right side continuity. I have never told that it will satisfy the both side continuity. When you come from the above or right hand side, it will satisfy the continuity. It is discontinuous. We have never claimed that it is continuous. This is in general true. But when we will introduce the continuous valued random variable, you will see that CDF is continuous. Both left limit, right limit are same. But in general, this is the criteria of a CDF, and that satisfies all the necessary things.
Okay, sir.
If it is continuous, well and good. But a discontinuous function can be a CDF if these conditions are satisfied. Is it okay?
Yes, sir.
Hello? Hello? Revise the limit definition of the limits and continuous function. Mathematics is highly needed for this kind of subject.
Sir,
Yes?
sir, I have a doubt in note 2.
Okay.
Sir, if Gx is the CDF, then Gx will be the random variable, no?
No.
X will behave as a
Fx,
random.
fx is a random variable.
No, okay. Understood. Yes, sir.
So I am talking about in general any function. You define a function from real number to 0 to 1. Call it gx. Check whether these four conditions are satisfied or not. If satisfied, you will find a random variable which x, capital X, which will satisfy necessary properties, which are mapping from real number to omega to real number. There will be a sigma field, there will be a probability function. All those things you will be able to construct. That is what is NCO. But this is a more sophisticated theorem compared to these claims. Okay. So see you tomorrow morning. Thank you.
Yes, sir.
Huh?
Thank you.
Thank you, sir.
Thank you. Revise the mathematics very well.
Thank you, sir.
Yeah, your 10+2 level and as well as math 1, math 2, especially the real analysis part, series, sequence, whatever you have studied. Please revise and come. It will be helpful for tomorrow, and not only tomorrow, for rest of the course.
Sir, for every random variable, will we find such a function?
CDF, yes, of course. CDF is the only thing that characterizes the random variable. Because what value a random variable will take, that is not a deterministic thing. It depends on the input. The law of association from the element of omega to real number, that is deterministic. But what will be that omega, that is not known. So if I toss a coin, I will get head and I may earn 1 rupee. You may toss the same coin, you may get tail, you may lose 1 rupee. So you cannot tell that this is greater than that, or in this way the comparison of random variable are not possible as the comparison of real numbers are possible. So to identify the property of random variable or random numbers, you need to go by its cumulative distribution function. Through that we can do the comparison. We will gradually see all those things. Probably it will be much more clear tomorrow. Okay.
Sir, will you also upload a tutorial?
Tutorial, there is no tutorial. It is 300 course.